This video is going to look at the trigonometric ratios of sine, cos and tan. The important thing to remember here is that you only use these trigonometric ratios in a right angled triangle. And it's very important that we know how to label a right angled triangle in order to use these ratios. So the opposite is basically the side that's opposite the angle that we're looking for. So in this case, A is the angle, so this side of the triangle here is called the opposite. The adjacent is the side that is beside the acute angle. So we're focusing on this angle, so the adjacent is basically the side that is in essence adjacent to that angle. And last but not least, the hypotenuse. Now that is always the side that is opposite the right angle triangle, or the 90 degree. So the 90 degree angle is here, and the hypotenuse is the side that's opposite that 90 degree. In most cases, it's generally the longest side of the triangle. Sine A then is used when we have either the opposite or the hypotenuse, and we can make it into a formula there. Cos A is used when we have the adjacent and the hypotenuse. So what I mean by that is that we know the value of each side. And tan A is used when we have the opposite and the adjacent. And we're going to look at an example of that now. So here we have a right angle triangle, and I know it's a right angle because of this 90 degree here. I also have the hypotenuse, which is 10, 8 and 6. Now the hypotenuse is 10 and it will not change, but the adjacent and the opposite will change depending on my angle. So for this example, I'm going to find sine A, cos A and tan A, and you're going to find sine B, cos B and tan B. So I'm going to rewrite this triangle now to only have angle A in it. Okay, so now you'll see that I've just basically copied this diagram and just removed the angle B, because my focus is this angle A up here. Now, the most important thing when you're answering questions on ratios in trigonometry, always label your triangle, because you'll be very surprised how easy it is to get mixed up with these. So that's what you do first and foremost. So straight away we're going to have this is our hypotenuse, 10, because it's the angle opposite the 90. And because we're dealing with angle A here, 8 is our opposite. Because remember, the opposite is basically the side that is opposite the angle we're looking for. So 8 is O. And then by process of elimination, A is 6. And that's the adjacent, because it's the side that is adjacent to the angle. Now, I'm looking for sine A. So sine A is the opposite over the hypotenuse. So very simply, all I do is I write sine A equals O over H. You can shorten it down. You don't have to write out opposite and hypotenuse every time. And then O is 8 and H is 10. And then you further break that down, because 2 divides into both of them. So 2 into 8, well, we know 2 goes into 8 4 times, and 2 goes into 10 5 times. So 4/5. And always simplify it if you can. Cos A then is simply the adjacent over the hypotenuse. So in this case then we have 6 over 10, and again they both divide by 2. 6 divided by 2 is 3, 10 divided by 2 is 5. So we have 3/5. And then last but not least, we have tan A, which we know from above is opposite over adjacent. and that leaves you with 8/6. And that breaks down to, well, we can divide by 2, so it's 4/3. Your task now is to find sine B, cos B and tan B. So for that you'll be focusing on this angle B here, and your labels for the opposite and the adjacent will change, but your hypotenuse will stay the same. So pause this video now and practice that. Now that you've tried to find sine B, let's put a bit more practice in with these 3 triangles up here where you're looking for just angle A, and down here it's a little bit trickier, you're looking for angle A and angle B. Remember to refer to your trigonometric ratios here and be sure to label your triangles appropriately. And remember, this can only be done when we know it is a right angled triangle. So now we're going to practice some calculator work. Now most of you will have a Casio calculator, scientific calculator, as shown here. And if you don't, it doesn't matter because you will still see sine, cos and tan on your calculator. So this is just to show you where it is on a Casio. But if you look hard on a Sharp as well, you'll find them. Now, when you're told to find sine 52, it's very simple. You literally press the sine button and then you type 52 and press the equals. So let's try that now and see what answer you get. So you'll see from your calculator that you get 0.78801 and it goes on further. Now we were told to round each one correct to 4 decimal places. Well, if we're going to 4 decimal places, it's just going to be 788. So 0.788. Okay, let's find cos 45 then. So just tap cos 45, cos and then 45 and the equals and see what you get. So this is a little different now because you'll see that when you get cos 45, it actually gives you √2/2. Now you were told to correct to 4 decimal places, so to change this into decimals, you simply press the SD button and you'll find that it'll convert it into a decimal form. So you've gone from a fraction to a decimal. Now let's find tan 22 degrees. So you'll see from this that tan 22 degrees gives you 0.40402 and so on. And we only need to round it to 4 decimal places, so it'll be 0.4040. And that's how you use your calculator to find the degrees of each ratio. And don't forget that if it's given in this form, like it was for cos 45 degrees, always press your SD button to convert it to a decimal. Okay, over to you guys now. Find the value of these ratios correct to 4 decimal places. Remember guys, make sure your calculators are in degrees and not radians, or you will get the wrong answer for all of the above.